Hello everybody. Now we will go over an example for a portfolio optimization problem with three assets. Here is the setup. We are given three assets and the individual returns and standard deviation for individual assets. So asset 1 promises a 5% return with 5% standard deviation. Asset 2, 10% expected return, 8% risk. And asset 3, 18% expected return and 11% standard deviation. All right, so maybe I can even go ahead and highlight these. Let's go ahead and highlight this one in yellow. I love colors, right? So let's go ahead and highlight this one, say blue, I guess. And finally, this one, we can either do orange, light orange. There you go. Awesome. So we have those three assets. Those are the expected returns for individual assets and the standard deviations. We're also given the correlation coefficients between these assets. Let's change this one to a 0.5. There you go. So asset 2 and asset 3 are relatively more correlated compared to asset 1 and 2, which are negatively correlated in a sense. So you will get more diversification benefits by mixing 1 and 2 in your portfolio than mixing 2 and 3. So now the next step is to construct the variance covariance matrix, and we've done a couple of examples about that, especially the case the two asset case. Pretty much the same idea. So the main diagonal, and let me just go ahead and so this main diagonal, let me go ahead and highlight it, will consist of securities, the three assets, the standard deviation squared, right? So let me also go ahead and do that one. And oops, it didn't work. There you go. And finally, the last one is the orange one, I guess. I think it was this one. Okay, so basically this one is so because we are comparing the asset 1 covariance against itself, so that's really the variance. The variance of an asset is just the square of the standard deviation. There you go. And the same thing for the other two assets. So asset 2, we're just going to square this one. And for asset 3, we are going to square the standard deviation of asset 3. There you go. So next, we need the covariance between asset 1 and asset 2. So this will be equal to, the standard deviation of asset 1 times the standard deviation of asset 2 times the correlation coefficient between asset 1 and 2. And enter. So, and the other entry, the symmetric entry with respect to the main diagonal, this entry, row 1, column 2, should have the same number. So just press enter. We still have two more entries. And by the way, this entry here will be the same as this one. And this one will be the same as that one. All right. So all we need is to first find the covariance between asset 1 and 3, just using the same idea. The standard deviation of asset 1, standard deviation of asset 3, and the correlation coefficient between asset 1 and 3. Press enter. And equal to the covariance between asset 2 and 3, standard deviation asset 2, standard deviation of asset 3, and then finally multiply the correlation coefficient between those two assets. So we are done with our variance covariance matrix. Next is to construct a portfolio. So now what I will do is I will go one step further. So I will give a target return. And what I will do is for multiple target returns, I will calculate the minimum variance for each and every, or the minimum standard deviation for those target returns. So basically, I'm asking my client how much return they want on their portfolio. My client says, I want 8% return, and I'm constructing a portfolio with minimum variance or minimum standard deviation, which gives that 8% return for my client. All right, so the plan is the following. Because the assets that I have in my hand, I'm going to just invest in these three assets, and besides, I'm allowing for short selling, so meaning negative investments in those assets. So because the way I realize that the returns fluctuate between 5% and 18%, my target returns will start from 4%, and I will write out every single contingency, right? So in case, in a sense, I'm creating a catalog, if you want. So whenever a potential customer says he or she wants such and such return, I will already have all the weights figured out ahead of time, right? Okay, so that's the idea. So so that will be portfolio 1 and so on, portfolio 2, and I will just, so what I want is to construct different type of portfolios for all different contingencies. So if a risk averse client shows up and he says, I'm okay with lower return, just make sure my risk is not too high, I want to accommodate them. But at the same time, I want to accommodate another customer which asks for a higher return and is willing to take more risk. And finally, a really risk-loving client which wants at least 18% return on his or her investment. How much is the least risk he should be willing to take in order to achieve that 18% return, and so on. All right, so what I did is, because these will be the weights, so for each different portfolio, I want to first of all make sure that the sum of the weights always add up to 1. Oops, sorry for that. So I need to, okay, it's messing up. Oh, well, it messed up already. Let's just do it again. Let's write that formula. There you go. So I want that number to be always 1, right? So that's the idea. So ultimately, all right. So right now, because the contents is 0 in that row, the sum of that row is 0. The sum of the weights in that row is 0. So we want the sum of each row to be 100%. I want to spend all of my investment to those 3 assets, basically. All right. Next is to actually construct the portfolio return and standard deviation. So portfolio. So this is the portfolio return and standard deviation. Let me, for different contingencies. There we go. Let me just go ahead and use this color, I guess. No, I didn't like it. Let's have this weird yellow. It's gold. Okay, gold is good. Or gray. Gray is too dark. Light gray? Yeah, light gray is good. All right, so obviously this is the least thing that you should be worried about, the color of the cells, but anyhow, it's fun to when the colors are nice. All right, so the return will simply be equal to, so matrix multiplication, we've done this many times. All I will do is I will multiply the weights, which is a horizontal vector, with a vertical vector of return. So because my vector of returns is horizontal as well, I need to first take its transpose. Transpose means make it vertical. If it's horizontal, it makes it vertical. If it's vertical, it makes it horizontal. So because the weight matrix is a 1 by 3, 1 row and 3 columns, and this one, as soon as I make it vertical, it becomes 3 rows and 1 column. When I multiply them, it will end up being a 1 by 1 matrix, which is just a number, which is a good thing. All right, so and then I'm just taking the transpose of this monster. Before I close the parenthesis, I want to make sure I fix that one. So I press F4. It fixes that. So the benefit of that is when I drag it down, I will be able to do so. So, and then because it's a matrix multiplication, I'm going to press Control Shift Enter. All right, right now the value is 0 because these are blanks. As soon as some numbers come out here, we will see the value will change. So next is I'm going to just go ahead and scroll this all the way down. So I mean drag this all the way down by left clicking it. Perfect. And just to confirm things worked out as I wanted to, you can see the formula on top here. The only thing that should change is this B18 D18, which is really the name of the portfolio. For instance, for that row 10 or row 27, portfolio 10, so these cells are B27 all the way to D27. Let's see if that formula is correct. The corresponding formula is B27, D27. It seems correct. All right. So next is the standard deviation. This one is a bit more annoying. So matrix multiplication again. The first array is again the weights, comma, and then we start a new matrix multiplication, and that matrix multiplication will have the variance covariance matrix, but I need to fix it first, and then comma, it will be the transpose, and we've done this many times again, the transpose of the weight function again. That's it. And we let the weight function flow, so I don't put any dollar signs. I'm not trying to anchor it. The only thing that I did anchor is this one. All right, and then Control Shift Enter. There you go. And then I can double click and it will it will just take it all the way down. So I will construct these hypothetical portfolios. In each case, I will calculate if I have a client who wants a 4% return, what type of portfolio can I recommend for that client, basically. That's the whole idea. Awesome. So let's just go ahead and do that. We're going to repeatedly use solver, right? So, and here we go. So I go to standard deviation. This is the objective that I have. I go to data ribbon, solver. If you don't see solver here, remember how to do it. So you go to file and then account, options, I should say. After options, you find add-ins, and then Excel add-ins, you say go, and then here make sure solver add-in is checked. All right, cancel. All right, so because I have it checked already, I can see solver here, and I press solver. I see the solver dialog box. Let me first make sure everything is reset. There's nothing there. So I can start the problem all over. So the objective is to minimize the standard deviation minimum by changing the values of the weights, these ones. And I want to add two constraints. First, the sum of the weights should be 1. Second, the target return should be this. All right. So the first constraint was the sum, which is this number, better be equal to 1. Just write 1 as a number, press OK. And second, add another one. We want that the portfolio return to be equal to that target return, which is this number over here, right? So, and then that's pretty much it. Press OK. Yeah, there you go. And then I'm allowing for short selling stocks or assets. So I'm unchecking this. And that's pretty much it. GRG here is something that we learned together. One of the G's, the second G here stands for the G in the gradient descent method. So this is, in a sense, a gradient descent method. I think it's a reduced gradient descent method, or generalized reduced gradient descent method. Pretty strong, powerful method for optimization. Sometimes if it fails, some people use evolutionary or some other optimization techniques. But anyhow, in our case, we're in good shape. Press OK, solve, and press OK. Perfect. So we now know exactly what proportion of our what proportion to invest in these securities, basically. So for instance, just to make it clear that everybody understands what's going on. So suppose that you are managing, invest, say, $1 million. $1 million. Oops, sorry for that. There you go. So if the investment budget is $1 million, so basically the amount that will be invested, okay, let me write it next to it here. Amount would be of those three securities, right? So, oops, Control X. All right, so you know what? Let me put it here. Control X, enter. So the amounts for asset 1, asset 2, and asset 3, oops, will end up being equal to that number times the weight, and press enter. Do you guys see that? So I know exactly what amount to invest in each of them. So I want to invest this times the weight for that asset 2 should be allocated to that, and finally equal to the investment budget times asset 3. Now, what does that mean, negative? So basically, we are selling $225,370 worth of asset 3, even though we don't own it. Can we do it? Yes, it's called short selling. So we are short selling these securities. A year later, we are predicting that the prices will go in the direction we want, and then we can buy it back. So this is a lot, so you guys can check it online. But because now we have, instead of $1 million, because we've short sold this, now we have $1.225 million, and as a result, we have more money to invest in asset 1 and asset 2, and so on. All right, but that's kind of the interpretation. Okay, so I'm not very worried about that. Next is, well, guess what? This was the good news. Life is easy. The bad news is you need to repeatedly keep doing that 32 times. Okay, that was an evil laugh. Okay, let me do it again. Let's see what we are against. Solver. Well, the good news is all the numbers are already there. All I need is just to modify them a little bit. So that 18 now becomes 19 because it's row number 19. So these two figures here, they will become, let me just delete that. So they will become the next row. So that's what we're changing. So the 18s become 19s basically. That's pretty much it. I can directly just, instead of deleting it, I can just say change, press OK here. And then the same thing here. The both 18s on both sides, they just turn into 19s. Do you guys see that? And press OK, and we are good to go. So this is unchecked. Say solve, press OK. So as you guys can see, this was our target. And as you guys can see, 4% target is reached. If you can take this much standard deviation. Let me just go ahead and make sure this column is also percentage. There you go. There you go. So yeah, we should be taking significantly less risk. Wow, so it's significantly less than I expected. That's a pretty good deal, especially if you want a low return. You don't have to take too much risk, it seems. But as the return goes up, you will see that the risk will also go up. If we change these numbers again, here the things will change. All right, so next is the third one. So pretty much by now we understand this is the row 20. So all the numbers, we will just change it to row 20. So this number will become a 20. These two numbers will become 20 and 20. This one will become change, make it a 20. Press OK. And then this one, say change, make that 20. Make that 20. Come on, 20. That's it. So we are again minimizing the standard deviation by changing the weights such that we achieve a certain amount of return and the weights add up to 1. And so far that has been the case. All these weights always add up to 1. So perfect. And there you go. So we are achieving 5% return. This is the amount of risk we need to take to achieve that. We keep going on like this. Oh boy, I did a similar mistake. I was supposed to put a square root sign. This is right now what I calculated is the standard deviation. Oh, holy. Oh gosh. Okay. Let's quickly do that because yeah, that we were looking for standard deviation. Sorry, this is just the variance. My bad. All right. So let's just close the parentheses one more time and then Control Shift Enter. The good news is the weights won't change. So solver will still give you the same result. So don't worry about that. Let's quickly change that one too. So we are changing it to square root. And make sure to close the parenthesis and additional parenthesis here. Control Shift Enter. And do the same thing here. On the very front, I attach a square root because the square root of the variance is standard deviation. The square of standard deviation is the variance. The square root of the variance is the standard deviation. All right, and for the rest of the problems, I'm just going to make sure the formulas are correct from now on. All I do is just add that square root, and there you go. All right, Control Shift Enter, and then I'm going to drag the formula down. Okay, there you go. I double clicked it. Perfect. Let's do it again. Data. Solver, 21st row now, I guess. Yes, we are in portfolio 4, which is on the 21st row. These things have changed to 21. This one is change to a 21. Press OK. Press OK. Change this one to a 21. That one is also 21. Press OK. And I think we are in good shape, right? This is unchecked. Press solve. Press OK. Oops. Okay. Awesome. So you guys can see the way the progression of our thing. Like I said, so we need to do it quite often. So one might wonder, wait a second, Dr. Null, is there an easier way to do that? Yes. Am I gonna share how to do it? No. Actually, if I feel like it, yes, there's a way to do it using the developer tab here. And so what you can do is you can record a macro, or basically you can write a code. Basically, I don't want to say write a code because it sounds scary, but you can record a macro that involves that solver in it, and you can repeatedly implement that macro. That's it. So that life should be pretty straightforward with that thing. Let me see. Yeah, so let me just go ahead and finish this the way I do. So at this step, I'm going to fast forward the video, but in your case, I would highly recommend, so let me just try to shoot another video regarding the developer tab basically. But for this one, let me not confuse you guys more. So we go to data, solver, we do pretty much the same thing over now. We are in the 22nd row. This thing is not 22, that's a 22. Oops. Change to a 22. This one is a 22. And then say solve. Okay, so by now you know the drill. Let me pause the video right here and then I'll finish it and then we'll be back. Okay, I completed the table, all the desired rows. So next what I will do is I will be graphing this picture, and to graph it because I don't want any errors, so what I'm going to do is I'm going to take this portfolio return and standard deviation, Control C, and I'm going to paste it right here on the side. Say Control well, I don't want to say Control V, right click, and I only want to paste the values. Next is I'm going to select these, Control X, and I want to make sure I carry it over there. Why did I do that? Because this is the x-axis, the risk is the x-axis, and the return is the y-axis. Now I can go ahead and say one more thing. Let me just go ahead and put percent signs. I think it's more handsome when we do so, and 2 more decimal place. Yeah, so that looks good, reasonable. So we go to insert, and I want to insert a scatter plot. There you go. So this is our Markowitz bullets, like we mentioned early on in class. So what I will do is I will do a couple of things to this picture. First thing is I will start the horizontal axis from 2%. So I can either format axis here or there's directly a dialog box showing up here. So let's just do it anyways. So I want to start it from axis options. Yes, there you go, axis options. So we said we want to start it from 2%. Instead of the minimum being 0.0, we want to 0.02. So this would be 2%. And it will still go all the way up to 14%. So I can better see the bullet. And for the top part, I don't want anything to see anything above 20%. So I just click on it. And the maximum will be 20%. There you go. So we can see the bullets, and this is all the this is the front here. So if my client tells me how much return he wants, say 12%, I can tell my client exactly the risk he should be willing to take. So this will be the minimum risk. Of course, you can achieve 12% by taking more risk, but if you don't want to take any further risk, you want to be anything inside the bullet is attainable, and you want to be on the leftmost part of the bullet. So that would be the point. 6.3% risk will do it. And if you're wondering, for my client who wants 12% return, I know exactly here the 12% return. He needs to invest in these proportions to those 3 assets. $329,979 invested in security 1, asset 1, $213,000 invested in asset 2, and $456,000 invested in asset 3 will have an expected return of 12% with an expected standard deviation of 6.32%. So that's really, really good. One more thing, how about the benefit of diversification? I'm going to do this additional stuff. I'm going to add to the bottom of this table 3 additional data points, and let me just go ahead and highlight them in yellow. So those 3 data points will be the 3 original assets. I want to show to you guys that diversification was useful actually. So what I will do is 5% return, 8%, 10, and then 11% and 18%. So there you go. So we add a 5%. A standard deviation will give us 5% return. I forgot the other one. 8% standard deviation will give us 10% return. 8% standard deviation will give us a 10% return. And finally, an 11% standard deviation will promise an 18% return. So now what I will do is, because these 3 points are not part of the data, so when I click on the data set, you guys will see that the last 3 numbers are not selected. So I will, what I will do is I can go to design, I think, and select data. And I want to make sure I include those 3 data sets as well. Instead of from M2 to N34, I want to go 3 more rows, N37, and press OK. Now when I check the table again, yes, those 3 are also selected. Now look at the picture. Wow, 1, 2, wait, where's the third one? Oh, the third one ended up being way above the, because it has 11% risk. Okay, where is the third one? 11% risk will give us 18% return. 18% return. Oh, it's exactly the same point. Let me check. 18% return is, yeah, it's extremely close. Those 2 points are extremely close. So what I will do is, all right, let me do 2 things. First, let me highlight this one as red. So this is one that we marker, and I want the marker color to be red. And I want the border to be red as well. The same thing for this point here, border, and the fill-in should be red. There you go. Now, in order to see the difference between the other two, there are 2 points here, if you believe it or not. So this one, the one that I selected is, I think, yes, it is the one that I need. So, and then let's make this one red and this one red as well. So like I said, there are 2 points over there, the blue and the red. One way to see it is if I were to really make the picture a little bit larger. There you go. Now you start seeing that blue point as well. Okay, so maybe something like this. Do you guys see that there's another blue point right underneath? So basically, if I did, if the diversification had no benefits, like, or if you were planning not to diversify your portfolio at all, in order to earn a 5% return, you would have invested in that security, but you would have you would have had to take a 5% risk. However, here, we can still earn that 5% return with taking only 4% risk. Do you guys see that point? Is 4% risk, but still 5% return on the vertical. The vertical axis is the return. So this is the benefit of diversification. So instead of, let me just move it up. So instead of trying to earn a 5% return with 5% risk, we learned that this point is, I think, the third point. So let me just go back to there you go. So the portfolio. So in my portfolio, that 5% return, instead of investing 100% in asset 1 and nothing in asset 2 and 3, if you mix these 3 assets in those proportions, you will still have a 5% return. However, you were able to reduce the risk to below 4% actually. So you reduced risk from 5 to 4, which is a 20% reduction in risk, a significant amount of reduction in risk. It's like, you might think that it's not that significant, but when you think about it, for instance, suppose that there's a good example would be, in any given year, there is 100, let's say 250, or consider a 4-month period. In a 4-month period, there's roughly 100 days. In a 100-day period, you are saying that the old method tells you that in a 100-day period, you will have 5 accidents, versus in a 100-day period, you will have only 4 accidents or 4 defect products and so on. So you are able to reduce your defects significantly. 20% reduction is a big thing. And it turns out that the reduction is even bigger depending on, for instance, here, if you want to earn 10% return, you could have either directly invested in security 2, 100% of your investment, $1 million, you could have invested in asset 2, you would have earned 10% return in average, but you would have had to take 8% risk, 8% standard deviation. Now with our portfolio, we are able to get that same 10% return by taking only 5% standard deviation. 5% compared to 8% is more than 30% reduction, or 35% reduction in the standard deviation. So that's a really good thing. So in this exercise, I think we were able to, let me go back and reduce the size of this thing because it's pretty annoying actually. Let me just get rid of this as well. Yeah, this is way too big. But yeah, so we were able to draw the picture for the for the Markowitz bullets, and actually let me try to fit it right here inside this area, so everything will be in the same picture. Oops, let's do it again. Come on. No, it's not gonna do. It's not helping me. My mouse sometimes is creating all this trouble. Let me try this one. Oh, there we go. There we go. All right, so we just started with the given information about three assets. Actually, these were the only givens. And then based on the givens, we were able to first, oops, how did I manage to do that? So yeah, my mouse is messing up here. So here we were able to derive the variance covariance matrix based on the givens, and then constructed all these hypothetical portfolios. And using those hypothetical portfolios, in each case we use solver optimization, a quadratic optimization, and we were able to ultimately derive this bullet, the Markowitz bullet. Sometimes this is, most of the time in technical language, this is referred to as the efficient frontier. And then we were able to compare it with the initial three securities. We realized that we can get as much return as the initial securities, but by taking significantly less risk. So which was something pretty good. Hope this was useful, and looking forward to see you guys in our next video, in which I'm going to still use those three assets, but this time I'm going to, in order to construct this bullet, I'm going to use a simulation. I will simulate 1,000 data points, and then I will try to show that we will still get that same picture. Hope to see you guys then.